But I'll try and share the slides. At any point, if you've got a question, just talk, feel free to interrupt, basically. How do I share? Here we go. This might work. Oh, I've disappeared, but can everyone see that?
Yes.
Hooray. Okay, like I said, just interrupt, it's fine. Any point if you've got any questions. So I work at the Element Institute with Xingdong, and we work for a guy called Rob Davey. So I'll give you a brief overview of kind of how we're funded. So we're a research institute in the UK, and we're funded on a sort of an example grant, the first of its kind, really, by a research council in the UK, where it's funded across 8 different institutes, and there's 25 groups of scientists. And the idea being that they could get more value for money by funding all these different groups to work together. And the goal of the whole project is to try and effectively reduce the amount of wheat that can be grown in the fields, because modelling forward of how much wheat will be needed for global demand by 2050, we're going to need an extra 60%. So we need to grow much more as possible. And since it takes about 15 or 20 years for current research to make its way into the field, it's imperative to try and start that process. So under DFW, so that's Designing Future Wheat, is the name of our grant, because they're so long, I'll just say DFW quite a lot. And we produce lots of scientific data. So we have things like field trial experiments where people will take crops and plant them in the field and go, does this work? Does this grow quicker? Does this protect against certain diseases? As well as that, we have different ideas of data sets or genomic sequences and all manner of different scientific output. And on top of that, we have loads of different types of users. So we have breeders that will have different needs from, say, academics or data science or people in industry. So the challenge we've got lots of different types of data, and we've got lots of different types of users, and how we can make that data accessible and usable for everyone. So what we've done is we've come up with a set of software, or a software platform, which we call Grassroots. And the idea about this is it's taking both industry standard software tools, but also our own custom ones that we make, and wraps them all up. And it's all open source. And the idea being that as long as you can speak in JSON, which I guess everyone who's working with Frictionless probably can. So we have a consistent JSON API, so it could be accessed from any other system in the world, and people can use it. Also, the idea that our instances of Grassroots infrastructure can be federated together, the idea you can join 2 together and sort of amalgamate their resources and try and make sure that everything is shared in a fair way. So apologies if everyone already knows this, but the fair data principles are four ideals for how to share data. The first is findability. So the idea being that data is accurately described with metadata, and that people and computers, I should say, should be able to find that data by doing a simple search. We're all used to stuff like Google now, and the ability to just type in a term and pull back the relevant data sets and data that we're interested in. For accessibility, it should be that once people have found the data, they need to know how it can be accessed, whether it needs to be authenticated or authorized. And there's a standard communication protocol where you can get that data with a given identifier each time. In terms of interoperability, it's all very well saying we made our data available. And I've known people that have literally taken a database dump and put it on the web and go, hey, data's openly available, but it needs to be interoperable. Once you get it, you need to be able to use it. So it needs to be able to be integrated with other sets of data. So it should be formally described and well-defined sets of data. The final part is reusability, the idea being that we've done all this work, or you've got some research, or you've got some information you want to share. But if you want to share it, you want to make it as reusable as possible so people can actually get at it. Oops. So in terms of our Grassroots infrastructure, we've kind of got this kind of model where we sit everything behind an Apache web server. So Apache is a web server, is kind of the software that allows people to create websites, and it's or host websites, and it's probably the most commonly used on the web. And we have a set of libraries where we do very common things like how to do networking code, or manage servers or services, or all this kind of code for wrapping up how to access things through JSON APIs and so forth, and how we describe web services and their parameters. And between the two, we write a little module that connects the web server to our Grassroots system. The actual bit that's of interest, the bit that does all the scientific work, are what we call services. So we have things where we've wrapped up existing tools and made them into a Grassroots service, and we've also written our own ones. So we'll take you through a couple of our own ones later on. And there are various things like BLAR. So we have a BLAR service, which if you work in the science of bioinformatics, it's basically a search thing where you can type in a genetic sequence and look to see if that exists in any of the sets of data that you've got available. As well as that, we have things like a global search service and lots of work to do with field trials, which I'll describe a bit more. So one of the problems we wanted to address is that typically when you do standard web service interaction, you might go to a single web service and do a search on it, and then go to another one and do the same search, and then try and collate results together. So that if you're anything like me, that's prone to error, because I can easily make cutting and pasting errors, or when I collate things together, or I run the services with different sets of parameters so that they're not immediately comparable. And it's just time consuming. So one of the goals we have with Grassroots is that you can federate services together. So we have a Grassroots infrastructure running at our Earlham Institute, and also one of the partners on DFW is the University of Bristol, and they've got one running there. So we federated the two together. So the idea being it doesn't matter which system you access, you get to see all the list of services from both combined. And going further than that, it can do things like if you're running the same two different institutions, it can amalgamate the two together. So instead of having BLAR service listed twice, you're seeing a single BLAR service with all the listed data sets at both institutions. So from a user's point of view, it's like it's all in one place. So you do your search and get the results back, whereas actually under the hood, there's all this communication going back and forth between the different servers and amalgamating it all together. So I'm going to take you through, we'll go through a few of the projects we've done. So the first is our data board. So like I said, we produce lots and lots of data under DFW, and we're very big on open data and data sharing. And there's also all of the data that we produce is made available under the Toronto Data Agreement. If you hadn't heard of this, it's a really cool agreement where effectively you can share your data before you publish, which is quite a cool thing for scientists. So the idea being that you can then access it and other groups can access it and do their work with it, but you have first right to publish, so they can't publish until the original authors have. So that's a really good a license for doing that. And in terms of the actual software we use to host all that data, we use something called iRods, which if you're not aware of, it's an open source data management software, which is used by, like in research and also in corporate world as well, and in governments. And it has the idea of data virtualization. So the idea being it doesn't matter where the data is stored, you can still access it through a common API within iRods. One of the cool things it has on top of like standard file structures, the ability to attach metadata direct to the objects within an iRods system. So you can actually, for instance, you run an experiment and you want to attach metadata of like the parameters you use to run that experiment or any additional comments you've got, you can attach those to the output files as metadata. And if you move that data around in the system, it still keeps the metadata attached with it. It also has the ability to be embedded within workflows, and it can be made, you can have authentication on there, so you can have secure collaboration. And it also has the idea of, similarly how I mentioned for Grassroots, we effectively nicked the idea or paid homage to the idea of federating two iRods instances together so you can share the data between them. So we have this iRods system, but that isn't normally web accessible. So what we did is we took an existing Apache module that was on GitHub and we forked it. And the idea of making a nice website on top of that. So it automatically generates from the iRods listings or within the iRods file systems, it generates the websites for that, and you can customize that and configure it to make it look nice, which is always an important thing for user sort of experience, but as well make all the metadata available to both display and to make it editable as well. On top of that, we also gave it a full REST web service API, so we tried to make it so that as well as people just come to download our data, they could also embed any of the data we've got into their workflows to put it off. So in terms of the metadata we store, we have something called the minimal information about a plant phenotyping experiment, which clearly, because that's quite long, they made an acronym, so MIAPI. And that's an idea of a minimal set of data for describing what's been done in an experiment. So for each of the data sets we've got on our system, we have at least this on there. And this is a screenshot of some of the metadata we've got from one of the particular data sets. On top of that, we have things like everything will have titles, descriptions, the license details, what's data on there, and descriptions of what this data set might be about what type of experiment it was generated from. We have all of this embedded using our own custom Lucene-based text search engine. So Lucene is an open source attempt at trying to do something like Google, I guess would be a way to describe it. So we were lucky enough last year to win an Open Knowledge Tool Fund Award. Part of that was to expose all the data sets as frictionless data packages. So you can see here, for each, these are then automatically generated. So it's not like a user has to go in and fill out a long list of JSON or fill in a form. So it interacts with the iRod system, works out what files and directories are on there, and automatically generates the data package files. Of course, I'm in a frictionless data meeting, so I don't probably need to describe what frictionless data is. I'll skip that one. But so each of the projects within that, each of the packages that we create, they all have automatically generated the license details, the names, the descriptions, the authors, the title of the project, and also a unique identifier. And all of these, it's all done, like I said, automatically. So it's all taken from the metadata values that are stored within the iRod system. And it's all completely configurable, because we can't go to people and say, hey, we've got this great system for generating frictionless data packages, but you have to use these iRod's metadata keys to do it. That wouldn't work. So that's all configurable. So you can just write a little properties file saying, okay, take these metadata values from iRods and convert them into these frictionless data values. And it can amalgamate values together. So, and also it can deal with tabular data resources as well. So we have the idea for a similar thing that you can specify for particular CSV files or similar. These are the columns and these are the data types. Again, it takes those from the iRods and puts those into tabular data resources within the frictionless data packages. So that's all cool stuff. So we did that, and we love frictionless data. So we thought, so I'm going to talk about field trials now, and don't be surprised if frictionless data comes up in this as well. So for field trials, they're typically where readers or academics will have an idea of a particular problem they're trying to solve, a particular how to increase the yield of a crop, for instance. And they'll go and plant different species within the field and apply different treatments, be it fertilizer or whatever, and then measure maybe how quickly they grow or how high they grow and so forth. So we create a system for managing all this data. And again, we want to make sure that all the data is compliant with the fair sharing principles. So we had the idea of a Google Maps based approach of you can zoom in across the world and see what experiments have been done, as well as having a more standard text-based search form. And each of these lead you to the studies that are all on the system. So not just with field trials, but with everything we do, all of the data we do is openly available. So the accessibility part of fair data is just a given for all the work we do. And all of the field trials and studies have a unique identifier, so they can be accessed through standard web technologies as well. Now, in terms of interoperability, we initially started with something called BRAPI, which is a community-driven open source standard for plant breeding databases of describing how plants were breeded together. So we had that as part of our interoperability initially. And we have lots of sort of user-facing features, like the idea that it can, the people planting these experiments have very, very accurate GPS enabled drones, and on the tractors that actually plant the materials, they've got very accurate GPS coordinates. So we can store that so people can zoom in on the field and go to an actual plot. They can walk around the field in real time and it will update on their device. So they can see which plot they're in, so they can look up what crop was planted there and so forth. So in terms of reusability, we have various different sets of data installed. We have generic terms such as the length or width of a plot, so a plot being where one particular type of crop was sown, the date it was sown, and any particular comments and any treatments that were applied and so forth. And again, you can add sort of things like image files or anything like that to try and make it as much information capture as possible. All of these are stored with standard ontological terms wherever possible. And we also store phenotypes. So phenotypes is basically a measurement, as an easy way to describe it. So it might be, for instance, the height of the plant or how long it took to grow or anything like that. So typically they involve things like a trait, as in you're measuring the height. The method might be what you're using to measure it with. And the units could be, whether it be meters or centimeters or so forth, along with the actual value and the date that it was done. So all of these, again, as I mentioned before, everything's ontologized or semantically written up, and we try and use the crop ontology wherever possible. So I mentioned that we used the breeding API, BRAPI, and we have also our Grassroots APIs. And that's all well and good for exposing data. But a lot of the people that we work with aren't necessarily programmers or even necessarily comfortable scripting. I remember teaching at a workshop, and it was a real eye-opener for me. So for breeders and academics and people that know way more about biology than I could ever do, and their level of comfort is they wanted to go basically if Excel is kind of where they wanted to be and that kind of thing. So the idea of having all these APIs for them just wasn't appropriate. So we thought, well, how can we get around this? And the answer we came to was, let's use frictionless data again. So we went through the different types of data we've got in our system. So we have studies, and we have, they're parts of field trials that are part of programs. So all of these things, we created schemas for them and put those on the web. And another partner institution on the DFW grant is Rothamsted Research, and there's a guy there called, by the name of Rich Dostler, who he's big into frictionless data as well. He does frictionless data carpentry lessons. He's now starting up, and they've got similar kind of experiments, but much longer term. That could be like 10, 15, 20-year experiments. And again, he's looking to use frictionless data for that. So we're collaborating on that. So for each, again, all of this is automatically generated. It's not anything that a user has to create. It's all generated from within the field trial system. So we create these data packages that have various resources in them, and they tend to be the study, the program, and then like a tabular data resource, which is the actual equivalent spreadsheet of all the plots and stuff. So as I mentioned before, we have standard attributes like length of the plot, width, position in the field, and so forth. And also each study will be different. So each study will have different treatments applied to it, whether it be different fertilizers or so forth. And they'll also be measuring different things. So that's automatically generated as well from the field trial system. It knows for this particular study, these are the treatments that are applied, these are the things that are measured. So let's add those to the tabular data resource. And you can see, it might not be immediately easy to see there, but we've got various traits that were measured for a particular plot within the field there. So we got these into the data package, and that was great. But the problem that people still had at the other end was, well, how do we actually get stuff out of the data packages? Again, without scripts. So another thing we came up with is this idea of, and I've got to think of a smarter, nicer name for it, but the Grassroots Frictionless Data Tool, or whatever. There's got to be a better name. So any ideas are all welcome. But the idea being that it will, a tool that's cross-platform, so that people can point at a frictionless data package that they've downloaded, and it will go away and make it and convert it into some format that they might find more easily digestible. So currently we have the idea that general data resources can be changed into Markdown or to HTML, and for tabular data resources, we're going to CSV. And the point, another thing about this is not wheat specific. There's nothing in the code that says if not wheat, exit or anything like that. It's completely generic. So the idea being, I've got a little snippet of one of the data packages that we've done for one of the field trials here, and you can, it's got the general data package description along, and then it starts the list of resources. I'll just focus on the first one. So the tool will go through and go for each resource and look for whatever's in the profile, and then go over onto the web and download that profile. And then it uses that. So here's an example of some of that profile, and it will then use that to generate the actual report, or whether it be the HTML or the Markdown. So we've got here the snippet of this is that snippet in HTML. So it's generated. It's gone through all the keys from the profile and gone, okay, these are the keys, mark them up. Oh, the ones with the stars, it's gone, oh, these are the required properties, so put a star on to make that clear and so forth. So that's kind of what we've done with that. This is the initial version of it. So any feedback, good, bad, indifferent, ranting, is more than welcome. And any ideas, again, more than welcome. And I think I'm now going to pass you over to my colleague, Jingdong.
Sure. So another part of the tool fund we have is related to CCAN. We have a wheat CCAN for the Designing Future Wheat project. So this project involves multiple institutes and universities, and it generates a lot of research outcomes. Most of them are papers. We use this CCAN tool. It's a CCAN, I guess most of the guys here would know CCAN is an open open source data website repository. We use this CCAN to store all the publications across the institutes. Next page, please. So
oh, sorry.
Part of the tool fund was to expose the CCAN data as frictionless data package. Because of the time constraint, we didn't really want to do a full extension. So what we did was a simple Django app using Python. By utilizing the REST API of the CCAN, as well as already made that frictionless data package mapper that Lily sent me kindly, we were able to easily convert any of the CCAN datasets into frictionless data packages. Also, the Django app can push it back to the CCAN, the actual file, as one of the downloads, one of the resources. So if any of the resources in there is an Excel file or CSV file, the frictionless data package will also capture that and getting all the headers, so make it compliant to the tabular data package schema. So this Django app is really portable, so you can work with any CCAN installations. Just point the URL to that. Next page, please. So yeah, well, it doesn't look nice, so it's just for REST API. And next. Yeah, this shows from the tool, then it generates the data package.json and pushes it back into the CCAN site. CCAN use a key authentication, so only the person has write access can push the data back into that. Okay, next please. I think that's the last one. Oh, is that the last next page? Yeah, further work. So probably one of the things is to Dockerize the CCAN Django web app. That's mainly what I'm going to focus on next. That's probably Simon, you can chip in on the other parts of the frictionless data you were going to.
Yeah, I mean, as a general principle, we love frictionless data. So it's basically trying to increase the use of that. So we're looking to expand what keys and values we add to like describing the data sets, but also just wherever we can, we're going to try and shove frictionless data as a sort of output thing from our services. Yeah, so like I mentioned with Rich, we're looking at another set of work to take this and expose frictionless data for both single. So a lot of the stuff we do is for single year experiments, and he focuses a lot more on longer term ones. So I said like 10, 15 year ones. So we're going to collaborate more on trying to expose all of those as frictionless data and effectively come out with a set of common profiles that will suit both and expose all our weak data that way. Lots of people that we worked with, lots of names. So the Earlham Institute we work with, and some of the partner institutions. And you can tell us from the CSV conf, but I should say that's a big thank you to the frictionless data people, to the Open Knowledge Foundation for letting us giving us the money for the award in the first place so we could get started with this, and for all the help you guys have been. Great, honestly. And yeah, that's that.
Thanks, Simon. Thanks, Xingdong. That was a very, very nice presentation and super interesting. Does anyone have any questions or remarks? Or
yeah, hi. So thank you very much for the presentation. I missed this one, this conference, so I'm glad that I can hear it right now. I have a question. So what did you use frictionless data to have it in frictionless standard? Do you using it to validate data as well? Do you have validation layer?
So I'm probably the outlier in data science in general. I don't tend to write in Python, so I haven't been able to use any of the sort of frictionless APIs. So everything I've done is written from the spec. So in terms of how we've exposed our frictionless data stuff. It's all from like custom tools I've written. So in terms of validation, it's purely, it doesn't go any further than going, for instance, are these required properties? So it does that check, and also checks for the data type. So it goes, this property, that someone's name is a string, so make sure it's a string. Check that it's a string when it's come to import. But any further than that, no, it currently doesn't do. But the plan would be to try and, it's initially, like, it's a first attempt, I guess, at trying to get it all going.
Okay, thanks.
No worries.
Yeah, I have a similar follow-up question maybe,
Yeah.
which is thinking about how you're operationalizing this and how people are contributing. It seems like there's a lot of people contributing data sets themselves. So do you have any sort of like role of a data steward or somebody who is, ushering things along, revising data sets whenever they're uploaded incorrectly or not, not fully documented?
It's an interesting one because as part of our grant, it was put into our grant that everything, all the data would be made available. So this grant covers like I said, 8 institutions, and yeah, I mean, we haven't really got a stick to beat anyone with. We have to use the carrot approach. So like, even with people within our institute and stuff, we've got to try and show them, if you make this data available, you might have to do some work in terms of giving us the data and metadata that we need. But once you do that, look at all these extra things that we can give you for free and make your data more available so other people will be able to get at it. And one of the people we worked with really closely on the field trial system was a guy at Rothamsted Research who was initially quite skeptical about the idea, but it's now gone completely 180, and he's like the biggest cheerleader for it, which is ace. But yeah, I think if you go to people and say, right, make your data, you've got to try and basically convince people to do the extra work and go, and also show them that it's not enough just to stick a database dump on the web and think you've fulfilled the proponent of the grant kind of thing, because you don't. I've seen it where someone's literally just taken a SQL dump and just put it there with no documentation. You think, well, what use is that to anyone? So all we're doing with our tools is trying to show that by doing that, well, you get all these extra facilities for free that we're going to give you. So that's I think there's definitely a cultural thing of getting people to do that. So in terms of having a particular data steward, we don't have one. So there might be particular points of contact at each institution that are like the field trial data manager, for instance, at that institution. And by getting them on board, you hope then you can shuffle other people through as well. That's kind of the goal, yeah.
We have a data coordination task force. So each institute has multiple representatives to coordinate the data standards and what data to share as well.
It's quite a shift, because previously all of the institutes would used to compete for grants working in this area. So it's quite a new thing. So there's a culture of sort of secrecy that you've got to try and get past. So going to people like, by making your data open, everyone wins kind of thing. And once you get people on that, I mean, I'm preaching probably to converted here. So, but yeah, there's certainly cultural things we have to get past. But yeah, once you've done it, once you show them, once you've got tools that you can see, look at all this added benefit you get, then that makes it easier.
Thanks.
Hi, thank you, Simon and Jingdong, for the interesting presentations. I have 2 questions, actually.
Yeah.
One of them I have already written on the chat about. If you, I noticed that you're using custom data package profile. Have you encountered any difficulty in the frictionless data toolset? Because I've even noticed there's a bug there that
Is there? Okay.
Yeah.
I'll have quick.
Are you using friction? The tools, the tool sets from Frictionless Spy, and are you using these tools?
Because I've done it all because I don't program in C. I haven't used the actual Frictionless APIs, so I'm probably in a group of 1 in terms of like not being able to program in Python and not be able to use like the official API. So I haven't actually come across that problem. All the problems I've found so far have been of my own making, of my own bugs, and like not just reading more documentation. But I would say again, not trying to just praise people for praising sake, but I think the actual friction, it's been really good community. I think when if I've had issues or mentioned to Lily or Joe or Sarah or put things into the Discord or whatever, it's a really, you get answers, which is great. That's a really cool thing. So in terms of that particular bug, no, only by the luck of I didn't use that API. So that's my way of getting past that bug.
Yeah, me too. I've had an excellent experience with the team. They always address our questions and bugs really fast. It's just I got a curiosity because you're using a custom profile, so I thought that might have some extra difficulty. But if I may ask, the other question was about actually the FAIR principles.
Mm-hmm.
One of the principles determines that you need to have a unique identifier for everything, like data, metadata. What are you using there? Are URIs or things like that? And also about other requirements of the FAIR principles that are not so easy to achieve, like documenting the provenance in a machine-readable format, and also the process of documenting it is a challenge, and also the RDF vocabularies for describing metadata and everything.
Yeah, in terms of unique identifiers, we've got unique URLs, unique web addresses, and for each of the studies and each of the field trial and all the different parts of that system have a unique UUID. I want to say universally unique identified. I can't remember what the acronym stands for, but it's like 32, I think it's 32 bytes or something like that long. And I just use the tool on the system. So I use the UUID lib on the system automatically. So when people create a study, it generates it. So that's good. In terms of the data provenance, yes, documentation, I think, is probably the bugbear for every programmer, because you don't want to be documenting, you want to be coding, you want to do some right. So it's always more of a challenge. We don't tend, whenever we possibly can, we try to reuse an existing ontology. And one of the advantages of that, but also one of the downsides, is that someone else hopefully has documented it, so we can use their terms. I would say I found varying levels of how good the documentation is. So I think the stuff on schema.org and bioschemas is really good, really well described, with lots of examples. There are quite a few ontologies which I look at and I think there's not an example, there's no description. I have no idea how to use this. And it's probably my small brain, but I mean, I think examples always help. So in terms of, we haven't had to particularly generate much of our own ontologies. I mean, the schemas that we've done for these frictionless data things are about as far as we've gone so far, and it'll be incremental. So it was, let's do as much as we can to get this what we need, and then we'll add more documentation, because what you kind of hope for is someone comes up to you and goes, "What on earth are you talking about? You don't describe that well," and we can go, "Yep, that's a fair point," and then we can go and add the documentation for that part. And that's kind of just like an incremental process of ever increasing the documentation. But in terms of, I haven't touched any RDF or anything like that. It's like purely doing it in the JSON schemas. Yeah.
Okay, thank you again for the presentation and answers. And excuse me, I really have to go now. And hope to see you again.
Thank you.
Bye.
Thanks. Bye, Augusto.
Bye.
Thank you, Sarah. Bye. You all.
Oh,
also, the people from Minas Gerais, nice to see you here. And bye.
Yeah, I just seen Carolina's message in the chat. Yes, I'll try and ping the link to the presentation.
Can I still ask a question?
Yeah.
So I think it's similar to what Logan asked. In Minas Gerais, we are trying to create the metadata already as a data package, and it appears that you are only exposing as data packages. So I was hoping to hear a little bit more how we were actually collecting initially the metadata from whoever is actually like acting as a data steward. As
Sure. So we've got the MyAPI standards. So there's initial set of metadata that we go. So when someone puts a study onto the system, or onto the portal, there's MyAPI, and also onto our field trial system, there's sort of like forms they fill in to put it in onto the system. So there'll be things like notes of how the traits were collected, or how the measurements were done. There'll be comments on the actual for each individual plot. So all of this stuff gets, there's lots and lots of text-based forms, and similar things like almost like which way the field is facing, and whether it was on a slope, and what type of soil it was, and all of this gets captured as the metadata initially. So a lot of that isn't necessarily what people initially interested in, and won't initially be on the first sort of set of search pages, but when they drill down, that's available. So all of that stuff does get put onto the system and does get put into the Frictionless data packages as well. And again, it's all indexed and all searchable. Yeah, currently as it stands, there's like a set of required data and properties and a list of optional ones. So a lot of these come under the optional ones, but it's all like entered by the data stewards. We're looking to, in the next couple of years, start to automatically generate some metadata as well. So we're looking at doing some kind of AI analysis on like where we have lots of images, so drones taking of the fields, and whether we can measure the height of the plants from that by doing some analysis on the images and that kind of thing. So at the moment, all of the metadata is entered by the data stewards as far as that goes. We don't automatically generate. Does that answer the question, or did I ramble on?
Yeah, no, that's exactly it. And it's a custom application, right? Custom web application. Like you're not using, for example, Stickon to people.
Correct. We have the API system. So we have our Grassroots system, and we have like an API, a web service API on that, and that can attach to our data portal. And similarly, we're going to try and attach that to CCAN as well. So the idea that being, because you don't want people to submit data, the same data in multiple places. That's not a way to make it user friendly, or to make people go, hey, use our system, you're going to enter the same form 20 times. The idea being that they should be able to put the data in CCAN or in the field trial, and then it can automatically get populated across all other services, what we're aiming for again, trying to make the barrier for usage, for data entry, as low as possible, so you get people on board. I think that's sort of something we're trying as well.
Thank you.
Cheers.
Is there any other questions?
Yeah, I have another question or two. So I guess you had mentioned there's a lot of stakeholders in this system, and one of the ones you talked, maybe it's a little bit downstream, is like the data scientists. So are you, I guess, it would just be nice to understand a little bit more about like how Frictionless is actually useful to them. I mean, I think I understand, like, everybody wants things documented, everybody wants to be able to read things, that's fine. But is having this format actually providing uses downstream for people who are trying to work with the data? Or is it just, one example might be that like, well, it makes it easier to format and structure web pages that show the metadata. Like that might be one case. But in terms of actual people working with the information, has that proven useful yet?
We've got a plan for it. So I did. We are, as at the Institute, we're also part of the Cyverse initiative, which is like a global initiative for academic infrastructure, I think it's called. So we've got lots of computing power. So we've got the ability to spin up virtual machines on the fly, kind of thing. So the idea we've got is someone can go to one of these studies and go, oh, I really like that study. I want to look at the data in it. I want to do it into something, and say in R, I want to open an R analysis on it. So what we're aiming for is they can click a button, and that study will automatically get sent as frictionless data to another VM that gets spun up. They get the access to be able to log into it with the R system all set up and with the frictionless data package downloaded. So then we can have like sample scripts in there to like, we can use, I'm sure frictionless data already has this as part of the R package, but the ability to like then pull that data out to see if they can work on it straight away. So as well as making the data available, we're also going to try and make computing power resource available as well. Because again, some of these places, they might not have the computing power, or someone on the laptop might not have the ability to download terabytes of data or whatever, if that's the case. Whereas we can easily do that because we're all on the same infrastructure, the same sort of data platform. It's easy to make that data shared onto a new VM and spin that up. So that's kind of where we're going on that, yeah.
Okay.
I think there's stuff like, is it Jupyter and Shiny? There are various tools that, yeah.
Okay.
I had to make it there, yeah.
Cool. Yeah, and then I mean, I just have a few things that I wrote down. Another question I had was around like geospatial data. So I saw maybe this is part of the BR API, or maybe this is something that is part of it, but like irregular shaped plots that aren't square or that aren't, you know.
Yeah. So
like, is that well captured and handled by Frictionless in your experience?
Yeah. So we're lucky that the people do the experiments have these tractors with this super high, I think they're almost like military grade precision GPS, so that that all gets captured, and they've got all this GeoJSON files. So it's literally we can then. So from our point of view, it's easy because they just give us a GeoJSON. All the hard work is done at their end in terms of buying the high grade GPS equipment. But yeah, we can get that GeoJSON and yeah, absolutely capture it. And
as you're looking forward towards like drone imagery, do you think that there's been some discussion about like better raster-based descriptions? Is that something that you think is?
Yeah, I think one of the things I'm really keen on is the fact that they can obviously capture loads of images with the drones. They have the drones flying over the fields once or twice a day, so they can capture these images. So you can get like across these experiments are typically annual, so you might end up with like 700, 800, or 1,000 images of a particular plot. So the idea being that then you've got all these different plots within the experiment. You can then start to go, well, can I write some machine learning tools to actually try and parse these images and go, well, actually, okay, we think this is the height. We can go, this is the plant height across time, so we can produce these graphs. So that's what we're looking to capture, because we've got the accurate GeoJSON of the tractors and we've got the GeoJSON from the drones. We can tie the two together.
Yeah, and in terms of like metadata descriptor fields, though, like is that looking? I don't know if you've looked into this much. Like, is it sufficient? Is there sufficient set of common field names and resources for describing raster-based data? Well, this might just be an ongoing area too for Frictionless.
I think that would come down to what they've got on board the drones, but certainly what we've got are like common EXIF fields. So we've got, and certainly all the images they've got supplied to us so far, they've given us the common things like the date, but crucially the geolocation at the time of the drone of where it's pointing at. And yeah, obviously there's going to be some, we have to do a certain type of stitching the images together. That's something we have to do as well. But yeah, hopefully we can automate that. But at the moment there is kind of a manual stitching of someone having to effectively load them into the equivalent of GIMP. I think I'm not the person doing it, but they're effectively doing the thing of stitching all these things together. So yeah, we don't actually sort of supply that, but that's just something they've got on site. So they've got all this great GPS capturing equipment and the high res images from the drones. So that we're just simply the beneficiaries of it, and we go, hey, well, if you give us this, we might be able to provide you with automatic sort of measurements for free as well, kind of thing.
Okay, and then I have one last question.
Go for it.
Okay, so I think, it sounds like you're still moderately early on in this process and looking, presumably this is going to be a very long-term kind of system that's running. So looking forward for other use cases, one that maybe you just brought up right there was the idea of like combining multiple data sets to produce a new data set, produce a new publication. Do you feel like that sort of provenance tracking of this, this data set comes from these two or these three places that were combined in this way? Do you feel like that is being, you're going to be successful in capturing and describing that kind of relations?
Certainly, hopefully. I mean, it's a big sort of personal bugbear of mine where people put data on the web and there isn't the provenance. You can't get, if they put results from an experiment on there and they go, well, I use this scientific program to get these results, but they don't give you the parameters they used or the provenance of how the whole thing of how it's generated. That's sort of a bugbear of mine. But yes, that's certainly what we're aiming for, is the idea of the more of this provenance we can capture, the idea we can go, okay, we can combine these data sets. So we've got this information that we've taken from drones, we've got the information from the field, can we combine them together to produce a whole new data set kind of thing? Does that?
Yeah, I mean, I think so. Again, I'm just wondering like about the metadata, like is there the proper set of fields to describe that in a machine readable way? Like
hopefully,
I recognize that's a scientific intention, is to like be able to remix things, but
yeah, in terms of have we got that now, I'm not sure, because we're not at that stage yet. I would imagine, I wouldn't be at all surprised if we go, actually we need some extra to do the calculations we need. We might need some extra information to go back and get that.
yeah. And I've seen the web, what is it, the web provenance ontology, I think it's called, or the like data provenance ontology. There are some W3C ontologies that exist kind of to cover this, but that can be a whole mess to dive into, and often you also find that these ontologies don't actually work together, right?
Yeah.
Like, have
That's
some
a
other
nice
basic assumptions. Yeah.
Yeah, that's another sort of issue of mine, that it's easy to put stuff into ontologies, but the goal obviously is you want to be able to, unless you've got one single ontology that captures everything, you're going to have to talk between different domains, and you just hope that all of these ontologies are well described enough so that computers can automatically go, okay, this measurement you've got here is also defined in this ontology, so you can join the two together, that kind of thing.
Yeah. Okay, thanks for humoring all my questions.
Cool. No worries.
Okay, I think that sadly there is no more time for more questions, because I just wanted to give you a few announcements, so like talk about a few other things before we finish the call. The first thing is that we are publishing a frictionless repository. So that's a GitHub action for continuous data validation, and we're looking for feedback. So I'll share the link here in the chat, and it's also on the agenda anyhow. If you can have a look, and if you have feedback, that's absolutely great. And then the other thing that I wanted to share with you is that we are basically redoing all our sort of like web presence and all the websites in the appearance. So we are currently looking for testimonials from people that use frictionless data. So if you could write down in the agenda document a few sentences about your use of frictionless data and why you like it, why you use it, that would be absolutely amazing.
Okay. Can definitely do that. Can definitely do that.
Great. Then the other thing I wanted to tell you is that, announce you that the next community call is on June 24th. And we're going to have a presentation from Nikhil Vats on frictionless data package for Intermine. And there is a link to a blog, so you can already read about this project. Also, if any one of you is interested in giving a presentation in one of our next community call, let me know. There is in the agenda, there is a link to a Google form that you can fill out. And also, if you have any proposal of things that you would like to discuss, there's a dedicated section in the agenda that you can fill.
Can I ask a quick question about the GitHub Actions?
Yes.
Is it intended to replace goodtables.io?
I can do that one. We are starting that process of replacing goodtables.io and making it more functional. And I actually don't know if we will like completely replace goodtables.io with a new version, or if we will leave that as it is and just stop maintaining it. I don't know. We haven't decided that yet. So I would say that the GitHub Actions is like the first step in that process. Yeah.
Thank you.
But yes, currently GoodTables, or at least the continuous validation part of GoodTables, hasn't really been maintained in like the last year or two. So there's a lot of work that we need to do to get it more up to date and more accurate compared to the rest of the Python code, like the Python framework. And then we also have the browser tools, try.goodtables, which is for one-off validation, and we will also be doing those as well. And probably by the end of this year, we're going to try and get that done.
Thanks.
Then maybe the other thing that I wanted to mention, but we keep mentioning this since a few calls, is that also that we have vote on GitHub for the new frictionless feature that you would like to see. So go on that and vote. Yeah, and I think that's it. I don't have any other announcement to make. Don't forget to write your testimonials. Lily, do you want to add anything?
I don't think so. If you are inclined to write us a testimonial, even just a sentence would be great. You don't need to write us like a ton of info, but we will put it on the website and we probably won't edit what you write, or if we want to edit it, we will confirm with you before we do it. Yes, either way, we would confirm with you before we post it. Yeah.
So do you need that for today, or like just to plan the work?
As soon as you could do it would be wonderful, but I mean, you know, how about we say like early next week, if you can.
Awesome.
Yeah, thank you.
Okay, well, if no one has other questions, I'll say thank you, everybody. Thanks again, Simon and Xingdong. That was very, very awesome. And I hope to see you all in the June call.
Awesome. Thank you, guys. And see what, did
Thanks.
you say June the 24th?
Yes.
See you then.
Bye.
Bye.
Thank you.
Thanks.
Hi, everyone.
Bye.
All right, thank you.